Alright, hello everyone. Today we are going to be talking about square root with variables and how to simplify those. So before we get started with that, just a review from all of our perfect squares. In this box right here, I'd like you guys to write all of the perfect squares from 1 all the way up to 15 squared. Okay, so I'm going to start with 1 squared is 1, 2 squared is 4, 3 squared is 9, and I'm going to continue all the way up to 15 squared. So pause the video and finish that left-hand table for me. Okay, we will use that as kind of a guiding for some of our examples in the future, so just have that on the left-hand side of your paper so you can refer back to it. So now we're going to go ahead and look at square roots with variables. So if I had the square root of x squared, I need to think what number times what number is going to end up giving me x squared. Whatever number goes in this box right here is the answer to the square root of x. So if I were to plug in x times x, that would give me x squared. So the square root of x squared is just x. If I were to take the square root of x to the fourth, again, what number times what number is going to give me x to the fourth power? You got to think about those exponent properties. You should be thinking x squared times x squared. Notice how these numbers seem to be the same. So our square root of x to the fourth is going to be x squared. Let's just do one more to make sure we see this pattern here. Square root of x to the sixth is what number times what number is going to give me x to the sixth. You should be thinking x cubed times x cubed would give me x to the sixth. So the square root of x to the sixth power would be x to the third power. Okay, so notice how all of these exponents here are even because we're taking the square root. These are all square roots, right? Notice how you are dividing by 2 each time. So 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. Okay, so when we are taking the square root of variables that have an even exponent, divide your exponent by 2. So if even, divide exponent by 2. However, something you should be thinking already that not all exponents are going to be even. So what is that going to look like when I don't have an even exponent? Well, let's say I have something like the square root of x to the 7th. Okay, is there a number times another number that is going to give me x to the 7th? No, there's not, right? So instead, we need to split up. We need to break up x to the 7th. So break it apart. How can I break apart x to the 7th? Well, I could break it up into x to the 6th times x, right? If you guys notice here, could we simplify x to the 6th power? Yes, because it's an even exponent, right? It has to be an even exponent. If it is, we can go ahead and divide that by 2. So if I divide x to the 6th by 2, I'm going to get x cubed. However, notice I cannot do anything with my square root of x, right? I cannot simplify that any further, so I'm going to be left over with the square root of x. So the square root of x to the 7th simplifies to be x cubed times the square root of x. Alright, and let's just go ahead and do one more for you guys to go ahead and try. I want you guys to do this one. Square root of x to the 11th power. Go ahead and pause this and simplify the square root of x to the 11th. So if I were going to split up x to the 11th, the biggest perfect square I'm going to be able to take out is x to the 10th. It has to be an even number, the biggest even number, x to the 10th times x. So when I simplify that, I'm going to get x to the 5th times the square root of x. And that would be my final answer. Okay, we are now going to do 4 problems. Feel free to stop watching these videos once you understand how to do these, but I'm going to go through 4 problems that are very similar to your homework problems. So the first one here that we're going to go through. So our first problem is going to be the square root of 25 x to the 10th, y to the 12th. Well, why don't we kind of split this up into numerical versus just our variables. So I'm going to split this up. Square root of 25 times the square root of x to the 10th, y to the 12th. Well, what is the square root of 25? It's just 5, right? These are being multiplied together, right? So I have 5 times, can I simplify the square root of x to the 10th and y to the 12th? Well, they both have even exponents, right? So I can go ahead and divide both of those by 2, so it's going to be x to the 5th and y to the 6th power. Since these are both even, we can go ahead and divide that by 2 to get our final answer. So 5x to the 5th, y to the 6th is our final answer. Next problem. Number 2. We got the square root here of p to the 15th power. That was a terrible 15. Q to the 9th and r. Okay, so again, we're taking the square root, so I need my exponents to be even in order for me to simplify them. However, right now, they are all odd, right? So let's go ahead and rewrite this. Let's break it apart. So we need to think to ourselves, what times what is going to give me p to the 15th? Well, I could do p to the 14th times just p is going to give me p to the 15th power, right? Because my exponents, I would add them together and I would get 15. If I would go ahead and do q to the 9th, I want it to be even. So q to the 8th power times q would give me q to the 9th. And r to the first power, I can't do anything, so it's just r to the first power still. Okay, so now if I go ahead and look through this, I have even exponents with p to the 14th and q to the 8th. So those are the only two that I can simplify, that I can take out, that I can break out of my radical. Think about the radical as kind of like a jail cell, right? You can only come out of jail a changed man. So, right, when you take out p to the 14th, you're going to be left with p to the 7th, and you'll be left with q to the 4th outside, right? You can only come out when you're perfect, right? So the perfect square is going to come out. And then we're left over with everything else. So p to the first power, q to the first power, or r to the first power, and r to the first power. Now, you don't need to have all those first powers. You could also just write your answer as p to the 7th, q to the 4th, times just pqr. Either way, this answer is correct. Okay, I got 2 more for you. Next one. Getting a little more complicated as we go. So 245, u to the 4th, and v to the 4th. So let's go ahead and split this up into my numerical and my variables and deal with them both separately. Okay? So if I'm looking at the square root of 245, what is the biggest perfect square that I could take out of 245? What can I divide 245 by? This is where that left-hand side of your paper where you wrote all those perfect squares would come into handy right now. If you have a calculator, go ahead and start dividing 245 by your perfect squares to see what the biggest one you can take out is. Once you found that, go ahead and unpause this video. Okay, you should have found that the square root of 49 times the square root of 5 gives me the square root of 245. So I can go ahead and simplify that one step further. The square root of 49 is going to give me 7 square root of 5. And now I need to go and deal with my variables. Okay, when I look at my variables, I look to myself, are both of my exponents even? In this case, yes, they are. Both of them are 4. So when I take the square root of both of those, I'll be left with u squared and v squared, right? Because you're dividing the exponents both by 2 to get your final answers for your exponents. So when I'm writing out my final answer, I'm going to combine my like terms. So I've got 7u squared v squared times the square root of 5. And the very last problem here, a little more complicated. Negative 5 times the square root of 288, x to the 16th, y to the 10th, and z to the 7th. I know it's a lot, but take each step one by one and we will get through this. So first things first, let's split this up into numerical versus variables, and we can deal with each of those separately. Okay, let's go ahead and start with the variables this time. When I'm looking at the variables, I need to see, are the exponents even? X to the 16th is, and y to the 10th is, however, z to the 7th is not. So let's go ahead and rewrite this. I'm going to keep my even exponents. I need to rewrite, however, z to the 7th. And I'm going to rewrite that into z to the 6th times z. So now I have three terms here that all have even exponents. So when I take out my terms out of jail, right, I'm going to be left with x to the 8th, y to the 5th, remember we come out of changed man, and z to the 3rd. I will, however, still have a square root of z left over. Okay, now let's go ahead and deal with my square root of 288. If I were to split this up, I need to think, what is the biggest perfect square that goes into 288? You should be thinking 144 times the square root of 2. Okay? When I simplify the square root of 144, you're going to end up with 12 square root of 2. Now, I still have to remember both of these answers are being multiplied together. So I will have 12 x to the 8th, y to the 5th, z to the 3rd, times the square root of 2z. However, you need to notice up here there was a negative 5 outside of that radical, which means it's being multiplied by everything underneath there. So we need to bring that down, and we need to multiply this by negative 5. So really our final answer is going to be negative 60 x to the 8th, y to the 5th, z to the 3rd, times the square root of 2z.